Atomic structure, A-level chemistry. Let's recap on the model of the atom. John Dalton was the first scientist who described the structure of an atom, and he described an atom as a tiny solid sphere that cannot be divided. And then J.J. Thomson came with the Blum budding model. J.J. Thomson discovered the electrons, and he described an atom as positively charged balls with negative electrons embedded in it. Rutherford came with the nuclear model. So he tested the Blum budding model of J.J. Thomson, where he did his famous gold foil experiment. He fired alpha particles, which are positive particles, towards the gold foil. And if the plum pudding model was correct, then that means all the alpha particles should be deflected because the atom will all is formed of positively charged balls. However, what he noticed is that most of the alpha particles went straight through the foil, the gold foil, and only very few of the alpha particles were deflected. So he described the nuclear model. And in the nuclear model, he said that the mass of the atom is concentrated at the center and the nucleus is positively charged and the electrons are separated from the nucleus. The electrons are, the nucleus is surrounded by a cloud of negative electrons, and that most of the atom is actually empty space. So the Blum budding model was not correct. And then Bohr came and he discovered the energy level and he described the electron shell model. So according to Rutherford model, the nuclear model, the electrons are surrounding the nucleus and a cloud, but however, the electrons cannot exist in a cloud around nucleus because then the electrons will spiral down into the nucleus and this doesn't happen. So Bohr discovered by his experiment that electrons actually exist in shells or orbitals of fixed energy. As the electron shell is closer to the nucleus, it will have less energy than the electron shells which are, or the orbits which are further away from the nucleus. When electrons move between these shells, they will absorb or emit electromagnetic radiation of a certain energy. So when an electron moves from a lower energy shell to a higher one, it needs to gain more energy in order to be able to move to the higher energy shell, which has higher energy. So they absorb electromagnetic radiation. And if the electrons moves back from a higher energy shell to a lower one, then it will lose energy and it loses the energy in the form of emission of electromagnetic radiation. Later on, they found that not all the electrons within the same shell have the exact same energy, and they introduced the idea of the subshells. So each shell has more than one subshell because electrons have slightly different energy within the same shell. And that explained the bonding and ionization energy trends. Atomic structure and the subatomic particles. So we know that a nucleus is formed of a nucleus. The atom is formed of a nucleus. The nucleus can be found in the middle of the atom. It contains protons and neutrons. Protons are positively charged and neutrons are neutral. They are uncharged. And almost all the mass of the atom is concentrated in the nucleus. And then we have the electrons, and the electrons are negatively charged and they move around the nucleus in shells and they almost have no mass. So when we look at the relative mass for the different subparticles, which are subatomic particles, which are the protons, neutrons, and electrons, we find that the relative mass of proton and neutrons are 1 to 1, while the electrons is 1 over 1840, which means it's a very tiny when it comes to its mass, and we can simply neglect the mass of the electrons. When we look at the relative charge, we see that protons are positive 1, neutrons 0, and electrons minus 1. For an atom, which is a neutral atom, not an ion with a positive or a negative charge, the number of protons inside the nucleus equal the number of electrons that surrounds the nucleus. The atomic number and mass number, usually there are two numbers that represents any ion, any atom. These are the mass number and the atomic number. The mass number is usually written at the top left, and the mass number is the total number of protons and neutrons inside the nucleus, while the number that is written at the bottom left is the atomic number. An atomic number represents the number of protons inside the nucleus. And because the number of protons equal the number of electrons when it comes to a neutral atom, then that means that the number of electrons will equal the atomic number as well. For example, helium has a mass number of 4, atomic number of 2. That means there are 2 protons and 2 electrons for the helium atom, and then there are 2 neutrons. Isotopes. Isotopes are different forms of the same elements which have the same number of protons, but they have different number of neutrons. So all isotopes of the same elements have the exact same number of protons, but they can have different number of neutrons, which means the mass number will be different, but the atomic number will be exactly the same. Example of that is carbon 12 and carbon 13. Both of these have a mass, a number of, so an atomic number of 6 because they have 6 protons and of course 6 electrons for the neutral atom. And then the carbon 12 has a 12 mass number of 12, which means it has 6 neutrons, while carbon 13 has 7 neutrons. Because the different isotopes of the same element have the same number of protons and have the same electronic configuration, then that means they will chemically they will react exactly the same. So they have similar chemical properties. However, because they have different masses, they can have different physical properties. Some important definitions here that is needed for the A-level specification, which will be a bit different from the definitions we used to for the GCSE, are the definitions related to the relative atomic mass and the relative formula mass or relative molecular mass. So we know that the actual mass of an atom is very, very tiny and it's too small to be weighed. So the mass of one atom is compared to a mass of a different atom. The reference atom that is taken here is carbon 12. And carbon 12 is taken as having a mass of 12, and all the masses of all of the atoms are compared relative to the carbon 12. So now to define the relative atomic mass, the AR, the relative atomic mass is the average mass of an atom of an element on a scale where an atom of carbon 12 is 12. Relative isotopic mass is the mass of an atom of an isotope of an element on a scale where an atom of carbon 12 is 12. And then the relative molecular mass is the average mass of a molecule on a scale where an atom of carbon 12 is